In order to determine the trigonometric ratios of angle 45 degrees, first let me draw right angle triangle in its standard position. Let this be our y-axis, this be x-axis. And since it is 45 degrees, the angle will be in first quadrant. So let this be the initial side of theta, and it is rotating to make an angle 45 degrees, which is here. And this will be our perpendicular. So this angle here will be 90 degrees because it is an right angle triangle, and this angle here will be 45 degrees. I am labeling this triangle as ABC. Now we can write that angle CAB is 45 degrees. Next, our angle ACB, that is our right angle, will be 90 degrees. In order to find out the angle of ABC, we can use the sum of triangles rule. For all, the sum of all three angles in a triangle is equal to 180 degrees. That is, for all, angle ACB plus angle CAB plus angle ABC, which we don't know. ABC is equal to 180 degrees. We know that angle ACB, that is our angle C, is 90 degrees. So our angle C is 90 degrees plus our angle CAB, that is our angle A, is 45 degrees. Angle A is 45 degrees, and we don't know the angle of ABC, plus ABC is equal to 180 degrees. When we rearrange this equation, we will get angle ACB equal to 180 degrees, and now we are bringing 90 degrees and 45 degrees from left hand side of the equation to right hand side of the equation. So when we do that, the positive signs will become negative signs. So it will be minus 90 degrees minus 45 degrees. When we do the calculations, we will get angle ABC is equal to 45 degrees. 180 degrees minus 90 degrees is 90 degrees, and 90 degrees minus 45 degrees is 45 degrees. So now we have found out that our angle B is also 45 degrees. So now we can say that triangle ABC is an isosceles triangle because it is having two equal angles. Triangle ABC is an isosceles triangle. Now to find out the trigonometric ratios, we need to know the measurement of the sides of the triangle. So for that, first let me assume this side AC to be equal to as A. The length of the side AC is equal to A. This side of the triangle is equal to length A. Since it is an isosceles triangle, it is said that the sides of the triangle which is opposite to the equal angles of the triangle will also be equal. In this triangle, we have angle A and angle B to be equal to as 45 degrees. The side of the triangle which is opposite to angle B is equal to AC, and its length is equal to A units. So now we can also say that for angle A, which is 45 degrees, it is having the opposite side of BC. The length of this side of the triangle BC will also be equal to A. AC is equal to BC is equal to A units. So now we don't know the length of the hypotenuse side of the triangle AB. Usually this side of the triangle which is opposite to the right angle of the triangle, that is angle C, is considered as the hypotenuse side of the triangle. We can use Pythagoras theorem. That is, for all, the square of the hypotenuse side of the triangle is equal to the sum of the squares of the other two sides of the triangle. That is AC square plus BC square. So the Pythagoras theorem states that the square of the length of the hypotenuse side of the triangle, that is AB square, will be equal to the sum of the squares of the other two sides of the triangle. That is AC square plus BC square. That means length of the hypotenuse side of the triangle, that is AB square, is equal to the sum, that is addition, sum of the squares of the other two sides of the triangle, that is the length of the other two sides of the triangle, that is AC square, which is this one, and BC square, which is this one. So AC square plus BC square. So now in order to determine the length of this side of the triangle, we can rearrange this equation as AB is equal to square root of whole AC square plus BC square. Now we have the value of AC and BC. That is AC and BC. That is A. So now we can substitute that and find the answer. AB is equal to square root of A square plus A square, which is equal to 2A square. A square here will come outside of the square root. So it will be A square root 2. So this is our length of the side AB. So here the length of the side AB will be A square root of 2. We have all the three sides of the triangle. So now we can find out the trigonometric ratios. First one is sine 45 degrees. Sine theta is always opposite side, that is the perpendicular side divided by the hypotenuse side. So the side of the triangle which is opposite to 45 degrees is BC. This will be usually the perpendicular side of the triangle, that is BC. The length of BC is A. It will be A divided by the hypotenuse side. Hypotenuse side will usually be the side of the triangle which is opposite to the 90-degree angle of the triangle, which is BC, whose value is A root 2 divided by A root 2. A and A will cancel out each other. We are left out with 1 divided by square root of 2. The next one is cos 45 degrees. The definition of cos theta is always adjacent divided by hypotenuse. So adjacent side is the side of the triangle which is adjacent to our theta, that is our 45 degrees. The side of the triangle which is adjacent to our angle theta, that is this one AC, this side of the triangle whose length is A. So it will be equal to A divided by the hypotenuse side AB, whose value is A root 2. Hypotenuse side will always have the highest length in the triangle. So that is why we are having A into root 2. A into root 2. So A and A will cancel out each other. So we are left out with 1 by root 2. Next is our tan, that is tangent 45 degree. That is our tan theta's ratio is usually opposite side of the triangle, that is the perpendicular side of the triangle divided by the adjacent side of the triangle, which is equal to our opposite side which we saw before is BC, and it is having a length A, which is here. So it will be A divided by the adjacent side. So the adjacent side is the side of the triangle which is adjacent to our theta. So this is our theta 45 degrees, and the side of the triangle which is adjacent to our angle 45 degrees is AC. We cannot consider this side to be equal to as the adjacent side because this side is opposite to angle 90 degrees. It will be considered as the hypotenuse side of the triangle. So therefore we cannot consider side AB to be the adjacent side. So therefore our adjacent side of the triangle which is adjacent to angle 45 degrees is AC, whose length is A. So it is A. A and A will cancel out each other and we are left out with 1. Next three trigonometric functions are the reciprocal of the first three trigonometric functions, that is sin theta, cos theta and tan theta. First one is cosecant theta, that is cosecant 45 degrees. Cosecant theta has the ratio hypotenuse divided by opposite or the perpendicular side of the triangle. So we can directly write it as root 2, but let us look into our diagram. So the hypotenuse side is AB, which has the highest length of the triangle, and it will be opposite to our 90-degree angle. So whose length will be A root 2. It is A root 2 divided by opposite side or the perpendicular side of the triangle. The opposite side of the triangle which is opposite to our angle theta. So our angle theta is 45 degrees and the side of the triangle which is opposite to 45 degrees is BC, and it is also considered as the perpendicular side of the triangle because it is making 90 degrees with our base, which is having an value A. So it will be A. A and A will cancel out each other and we are left out with root 2. Here we can see that it is the reciprocal of 1 by root 2. Next is secant 45 degrees. So sec theta has the ratio hypotenuse divided by adjacent. So hypotenuse side of the triangle, as I previously told before, is AB, which is opposite to the 90-degree angle of the triangle, which is having a value A root 2. A root 2 divided by the adjacent side. Adjacent side is our side AC, which is adjacent to 45 degrees. It is having length A. It will be A root 2 divided by A. A and A will cancel out each other and we are having 2. So here we can see that secant theta is the reciprocal of cos theta, which is having the value 1 by root 2 and secant theta is having the value root 2. And our last trigonometric function is cotangent theta, that is cot theta. In our case it is cot 45 degrees. And the definition of cot theta is always adjacent divided by opposite or the perpendiculars of the triangle. First is our adjacent side, which is AC, which is adjacent to our angle theta 45 degrees, which is having a length AA divided by opposite side. The side of the triangle which is opposite to 45 degrees is BC, and it is also perpendicular side of the triangle. It is having a value A. So A divided by A. A and A will cancel out each other. We are left out with 1. Here we can see that cotangent theta, cot theta is reciprocal of tan theta. So here we are not actually seeing the reciprocal, but it is fine. The reciprocal of 1 is 1, but cotangent theta is usually the reciprocal of tangent theta. So now we are having the trigonometric ratios of angle 45 degrees. Next we will be seeing the trigonometric ratios of the angles 60 degrees and 30 degrees. If you understood the concept, subscribe to the channel, like the video and share the video. Thank you.